Awesome. Dimitri, thanks for chatting with us today.
Yeah.
I am going to make you co-host, which is a necessary ingredient. Awesome. You know, co-host. We're super stoked about this. This is one of those like rare talks where more than one person said we should invite this person to come talk to us,
Okay.
which is great.
Cool,
Um,
cool.
I feel like you either need to like do something extremely stupid with type theory or like hack something in an interesting way to get that sort of response. So
I would
um,
love to know the other people. Yeah, I mean, I'm also interested in these topics, right? So like, yeah, tell me who the other ones are. But okay, that's cool.
Yeah, so I'm very stoked about it, and appreciate that you took the time to talk to us. And I've heard that your talk is very good because I have friends who saw it at a Rust meetup in Boston. Who said that it was a blast. I don't know if that was you or one of your teammates, but regardless, excited to host you. And yeah, you can share screen and we can get started whenever you want. There'll
Okay.
probably be a couple dings as people tend to join late, but it's their loss if they miss something.
Okay. So before I start, can you tell me like, can you give me a little more background on like you all and what like so
Oh
there's a lot.
yeah.
So I've given this demo something like I haven't counted, but more than 50 and fewer than 75 times. Uh,
Okay.
because I showed it to people while I was working on it a lot. So I have like, I can talk. One of them was 3 hours long, right? So one per, like someone had a lot of questions and we went in depth about things. So
Yeah.
like, we can go a lot of different directions. So it'd be nice to know in advance, like what, you all are interested in hearing about.
Sure. So I would say your audience today is predominantly graduate students.
Hmm.
Um, I recently graduated, but more or like half the people here are current graduate students. Holmes is a serial hacker entrepreneur in San Francisco, currently wearing ridiculous glasses that seem to be projecting you in 3D space, which is hilarious. Um, and Chris has a master's in mathematics. Anand, I don't know your background. I'd assume you're also a graduate student, but
Yeah.
okay. Yeah, so almost all graduate students, most of us in PL are formal methods. So you can assume pretty decent background knowledge. We have about an hour, and but if we go a couple minutes over, it's not a big deal.
Okay. All right. So let me share my screen.
Yeah,
Um, all right. So what we're gonna do is like a fairly technical, like you know, a fairly technical deep dive into how this whole thing works. It would be cool. I mean, everybody says this and nobody does it, but I would love if you all could ask questions as we go because it's like it's way easier to kind of facilitate the things that are like I was just asking. But so thank you for the broad sense of it. But like
sure.
it's cool to know like what parts of this to go deep into. I'm going to start by doing kind of an overview of how it all works, and then we'll dig into the individual pieces, and I can kind of pick apart how it functions. But there's a lot of stuff to talk about as well about like how I arrived at this design, how I like what the process was, what the testing is a very big part of this, which I think is interesting, but like what how the tests work and how do you go about even writing tests for a thing like this. So yeah, we can do that all, but the more you talk, the better it will be, I think, is how that usually goes.
Awesome. Sounds like a plan.
Okay. So the big picture is I think that so I don't have a computer science background. I have 4 degrees, but they're not in computer science. One of them is in linguistics, so that's like the closest thing. I do love learning in academia and all of that, but I just never thought I would be capable of being like a very good engineer when I was in the younger and deciding what majors I guess I would pick. Um, so some of these things I think you may laugh at, but I don't mind. You can laugh. I didn't know a lot of stuff about kind of systems level programming, about even like how binary math works and stuff when I got into this project. So, but I did know a lot about type theory and set theory stuff, like basic logic, symbolic logic type of things. And I think that there's this thing I've heard a few times, which years ago it was shown that the TypeScript type system is Turing complete. Let's see if I can find that. But it's an interesting. Is it going to be here? One second. So it's an interesting like mathematical proof about like the way the type system actually functions. And here I'll pull it up because it is kind of fascinating. TypeScript Turing. So when I hear this, and I hear people talk about it, so yeah, March 2017. Can you guys see this on the screen still? Still?
Yeah,
Yeah.
nice and clear.
Okay. So somebody like I don't know who this person is, but some TypeScript nerd was like, "Hey, there's this way that you can construct, you can like sneak your way into getting, Turing completeness." And I think that so, and then in the context of that, I had been making YouTube videos with this channel, Michigan TypeScript for actually, I should say, like before I even forget, you are all in Boston, and there's a conference happening in Boston. Are you aware of this? Have you heard of SquiggleConf?
I have not. I don't know if other people on the call have.
Okay, well, there's a conference happening that's like all about this kind of stuff. Like if you like what I'm going to talk about today, then you will definitely like this. I do run this conference as a kind of personal disclosures, but it's got a lot of compiler theory stuff, many of the kinds of things that are interesting. But anyway, part of the reason I got into doing this conference is because I run a channel on, Michigan TypeScript where we announced this, and we were doing these type challenge things. So there's this concept of type level programming. So does everybody here know what I mean when I say type level programming? Or is there anybody who doesn't, maybe? And I can explain what that means pretty quickly.
Yeah,
I,
brief overview would be helpful.
Okay, good.
yeah,
So whoever just spoke, let me show you something, and we'll see what you think about it. So there's this. Are you familiar with who was it that spoke actually? Then I'll call you out by name.
That's me, Anand.
Anand. Okay, so Anand, are you familiar with Conway's Game of Life?
Yeah,
So what happened was I talked to someone on my YouTube channel that was doing Conway types here. They implemented the game of Conway's Game of Life with purely TypeScript types. So like what we have here is we have a string in TypeScript's type system. Are you familiar with TypeScript?
not so
I
much.
Okay.
yeah, I think you have the whole
So,
spectrum. Chris
okay,
has never
great.
used TypeScript in his life. I code in TypeScript half the
It's
day,
it's
every day.
Okay, okay. It's cool. So TypeScript is a layer on top of JavaScript that provides typing. So like just like when you can say in JavaScript you can say like const x equals 1, right? And that's like valid JavaScript. But TypeScript takes it a step further, and you can say const x, number equals 1. And so like this part here that I have highlighted, like that part is what TypeScript adds to JavaScript. And so it's kind of like a thing that you can attach to JavaScript. And people have started realizing that because you have things like in TypeScript, you can say type um, colors equals, you can say colors equals string, right? And then you can do something else that's kind of interesting. You can make literal types as well. So you can say, yeah, the chat GPT or whatever this thing is that's on is going to give me a bunch of them, but let's just work with three for just a second. So then you can come over here and you can say, like, I don't know, fancy colors. And what you can do is, yeah, you can put, you can put some other stuff in here. And then I'm going to do this thing. There's this thing called 2/ that TypeScript people use where you can kind of see a type. And so that I can show you, but you can imagine hovering over this. And so you can see that I have started doing like some kind of basic templating purely in types. So this is not, this type syntax here is not part of JavaScript, right? This is a little bit more. And you could even parameterize this. So like check this out. Like I could say like let's say we want this part to be a parameter, right? So we could say like prepend. Okay. So then I could make this generic. Um okay. And then we're good. Okay. So this is on itself not going to do anything, but I can say fancy colors, and then I'm going to say ANAND. Is that your name? Yeah. So then you see what happens here is that it resolves to some other kind of thing. So like we kind of made like I mean, you can think of it like literally you can think of it like a function, right? But this is all at the type layer only. So there's no like a lot of languages, the type, it sounds strange to say only at the type layer because there's not like a distinction. It's like it's all part of the same thing. But JavaScript is a dynamic language and it's a piece of shit as well. And because of that, there's no rules. But TypeScript tries to add some of those rules back in. So this is kind of the building block that actually like what I've shown you here is 60% of what you need to get Doom running. Believe it or not, the type system has some basic stuff for math and numbers, but it doesn't have things like addition. There's no operations you can take. All you can really do is make strings and add and remove things to those strings, if that makes any sense. So if I showed you this, the code of this, you would see that like, wow, it's going to do we created some literals, like we have a cell here. So a cell is like an X or a dot. And if we go down to the end, we can see that like, okay, yeah, these are all X's or dots. Okay, great. And we can start saying the board is this is a cell array. So it's a two-dimensional array of cells, if you want to think of it that way. And then you start kind of building up these constructs where like this is addition. So like let's take a look at this because this is I mean if you're not exposed to this kind of stuff a lot, it may be a little strange, but I'm going to show you. So like to accomplish addition, like where this function actually just adds looks like it adds one, right? So what I'm going to do is I'm going to take in three parameters to my function. These are generic parameters, right? And they kind of have types, right? You see this extend syntax all over the place, and this is the way at the type layer that you say, just like I did in the thing that I built, that like, oh, I have a parameter, and the type of that parameter itself is string, right? If I say number, then I'm going to get a type error down here because actually it's going to say, hey, string does not satisfy the constraint number. I passed in a string. It really wants me to pass in here like a number, like one. And then you see the type errors go away and everyone's happy. Does that make sense before I get into like add and all of these things?
Yeah, yeah. This is completely clear. Thank you so much.
Yeah, for sure. So once you do that, you could start building up. You do little tricks, so you can start building up constructs that use other things within the type system. There's a funny fact about the type system, which is that I said you can't do math, but there is a trick. There's a workaround, which is that if I say so, if I make a type here and I say type sum array. I can make an array of, actually we'll just do strings, yeah, A, B, C, D. And then I can make a another type that has particular value. Yeah, let's show that actually. It's not so bad to see. So I can make a type that has particular values from some array. So I can just index into this uh, here. But I can also come in here and say length, because this is a valid property in JavaScript, and it just so happens that that is a thing that TypeScript understands for these kind of constant sets of things. In TypeScript, there's this concept of a tuple separate from an array. So actually, this looks like an array, and I've been saying the word array, but really at the type layer, it's a different thing called a tuple. It's kind of like how in Go or many languages they have a array which has a fixed length. So the type of the array is married to the length of the array. They're considered the one and the same thing. And then if you want to have a variable length array, then it's like a different thing. So in Go you have slices, or some languages vectors, in Rust and stuff like that.
There's
So it's a
also,
similar.
I think the
Please.
semantics of keys and values are really different from stuff I'd seen before TypeScript. Because like
Mm.
in Python, if you said like foo colon blarg, like foo could be a variable that could become like the word banana or something, right?
Yeah,
But
yeah.
in TypeScript, it's interpreted as like the literal fucking key foo,
Yeah,
which
exactly. Yeah, yeah, yeah. It has to
super
do that.
counterintuitive to me. Yeah.
Yeah. There's a lot counterintuitive. When you try to polish the turd, I mean, I should say, I am not a big fan of JavaScript, and I'm not the biggest fan there ever was of TypeScript. And that sounds maybe strange because I've dedicated so much of my life to doing TypeScript funny things, including this channel I've told you about, and the SquiggleConf conference, and these other things. However, it's just like you get doing what you get doing for work, and you find ways to have fun with it. But TypeScript is trying to make the best of a terrible situation, I think, that we're in with JavaScript. It's quite a shame that JavaScript is what it is today. But oh well, people have found ways to make it a lot better than it used to be, so we try to be happy. So in any case, what I can do is like you can imagine if I wanted to make like let's just like trivially try to make a function together here as a kind of like quick workshop on doing is that bell because I hope nobody's raising a hand or asking
No,
a
these are
question.
people
Oh,
joining late.
oh, okay.
Grad students are
Oh,
always like getting off a meeting with their
we got
advisor
two
10
people. Yeah,
minutes to,
that's all right. It's
yeah.
recorded, so who gives a shit? Yeah, I mean, welcome to you here. We're kind of giving an overview of the type system, but yeah, like so if you wanted to kind of trivially make like let's make a repeat. Let's just do something really simple. Repeat, and we're gonna do yeah, n extends number. Okay, see, this is not gonna be fun because the AI is gonna do it for us. But anyway, and now it's starting to bullshit. Anyway, it's interesting. I've just sort of started in the recent days turning on this like autocomplete stuff, and I find it a little demoralizing. But it doesn't matter. So let's talk through what this does. So I can come over here and I can call repeat. Um, so I'll say repeat type x equals repeat 5, and then let's do this. Um, oops. So we're going to use our 2/ syntax again, and it will show us here what it's going to return. So look at that. It has 0, 1, 2, 3, 4. Let's make it a little fun, more fun. We're going to repeat like some character some number of times, um, like char. Yeah, and then down here, instead of repeating array length, we're gonna put in char. Okay, and so now we're gonna have come on, keep going, Sally. Well, anyway, we'll talk through it. So if you think of this, so what's funny about the type system and what's funny about this stuff is there's no statements and there are no loops. There is looping, but there's no loop construct. Like you don't have for loops or while loops or do loops or anything. You don't have anything that kind of stuff. I mean, they did not intend like the people who created TypeScript. I can tell you for sure because I've asked them. They've been on this channel, right? And Anders Hausberg, the creator of C# and Turbo, Pascal, and also TypeScript. I got a great opportunity to interview him and show him this project, sort of shorter than I'm showing you now, but he knows this stuff. But he told me very clearly we never ever wanted this to be possible. This was not like a thing that we were trying to do. And I got another little quip from you from somebody else from the TypeScript team, and they said that like Dimitri, you did this in like the least hospitable environment possible. We were not. There's no like amenities for being able to do stuff like this, kind of general purpose computation. But anyway, so what's going to happen is I think there may be a bug here. So like let's see what happens. But so I have this number n, which is the number of times that I want the loop to recurse. Then I have a char that I'm going to be repeating, some number of times. And then we have a counter that counts how many times we have repeated so far. Actually, we don't need this counter, so I could make this better. But anyway, we can just use our accumulator. So let's just fix it. And they didn't even name it ACC. Man, these are fucking amateurs making this thing. Okay, so right into the function. So this is just going to be defaulted to an empty array. So this is like our result that we're accumulating. If you think of like a map reduce kind of situation. And so oh good, it has an error. Yeah, that should be an error. Char. So what's going to happen is and now it's recursing. We'll figure this out. So we're going to check the length on the accumulator. We're going to say, hey, have we met our end condition? Did we finish up? And if not, let's continue. And I'm sorry, if we did, then we're done. Then this is like the base case of recursion. Um, and then if we did, if we do have more slots, then we're going to keep going. So n stays the same. So we just pass n along through, and we don't modify n. Char stays the same. So this is the problem here. So we're not changing what the char is, but this thing, we're going to spread in. So this is a spread. We're going to create a new tuple, okay, brand new one. And we're going to spread in, that's what the syntax is doing, the current accumulated value. And then we're going to put that char on the end. We could put the char at the beginning too. It's because the kind of semantics of this function, it doesn't really matter. But the key thing for you to see here is that we're recursing. And we are tail call recursing, which TypeScript has a tail call recursion optimization built in. And this is a tail recursive. It can be statically analyzed by the compiler to see that it's tail recursive. And we can do arbitrary stuff. So like I could just as well put something else in here. Like I could put one and the end result is just going to put one. So we've kind of bypassed our char in this case. But you can start playing around and doing different things. I could return a string too. So like here, check this out. I could say ACC extends string. Well, okay, then we would need a some other structure. I don't want to get too stuck on this because we have a lot to talk about and I find this stuff too fun. But can you see how we could start building arbitrary logic? And now that I've shown you this, maybe this doesn't look that scary. This is saying like, look at the some n, see if it equals number. If that this is like a weird edge case, but like basically this stuff. See, this is very similar to what we did up here. This stop point number, compare it to the C length. This is like an equality check, so you could do it the other way around. It doesn't really matter. So you can start sort of see how you could build up like, well, we're going to add 0, we're going to create an array. And so what we're doing here is we're like basically like building up this big array with all these values. And then at the very base case of recursion, we're testing that to see like how many there's out of bounds stuff. Anyway, it doesn't matter. But in the end, like I can tell you just by like looking at this stuff a lot, this is the base case of recursion here, line 49, and we're going to stop there. So what happened was, so now we're gonna zoom back out and talk about the Doom project. So what happened was I started doing more stuff like this. I built a JSON parser purely in TypeScript types. That's another video we have on the channel, and it's like you start getting curious about these concepts like we were talking about with Turing complete. I think that people have this concept of Turing complete all wrong. I think that computer scientists are fooling themselves about what this really means. So, what we tell ourselves is that being Turing complete is a big deal. I think we tell ourselves that it's exciting to find out that a system is Turing complete. And my claim is that it's not exciting. Think about it. If I told you, hey, I have this thing in my basement. Come down and see it. It's Turing complete, and it will calculate the value 1 plus 1 only in 100 million years. It's not that cool. It's just not that cool. It's not that exciting. And this is the situation we find ourselves in with computer systems a lot, where we know there's these theoretical things like, okay, sure, yeah, but like the definition of Turing complete has a couple caveats that I think are very significant. One of which is that you have infinite time and resources. So you have like, you may need more atoms than there are in the universe, but then it's still considered Turing complete. And I think that's kind of baloney. And the second thing is like that I learned later, it's not even built into the concept of Turing completeness that you can iterate. So like printf debugging, like so printf, the function in C is the syntax of printf formatting is known to be Turing complete, but it can't iterate on its own. You need to call printf over and over again to like calculate things. So I don't know. I just don't think it's that interesting. And so what I wanted to do was I wanted to prove why Doom could not ever be run in the TypeScript type system. Like this is kind of like some sort of, you can think of this as the beginnings of a graphical thing. I didn't write this, by the way. This is like a guy that I interviewed on the channel that I was telling you about that got me thinking about this a little more. And you can sort of see, like you can sort of maybe dimly see now how like we can get from arbitrary values, we can like make ASCII art and stuff, but computationally, I thought the problem would be hit eventually that like, the TypeScript type system is not made to do anything even remotely close to this. This is like so far outside the bounds of what the type system is really made to do. It's made to do stuff like you were seeing with like red and like, yeah, there's some provisions in there for like adding to strings and removing to strings, but like surely that's not going to be good enough. And all I wanted to do was prove why it can't work, why it can't happen. And so I just set out on what I thought was like a 1 or 2 week, journey on trying to figure that out. And I end up proving myself wrong. That's kind of the nuts and bolts of the story. So
I
I want to
I
stop there
would
if there are any questions, please.
just add to your thought about like Turing completeness being boring. I think that
Yeah.
like something people tend to skip is that to do anything interesting, you need like some kind of syscalls or access to internet or access to files, or you
Yeah.
need to be able to like interact with the meta computer, the computer that you like care about that
Yeah.
has
Yeah.
things that are
A
sensitive.
black box that just gets really hot and then later
Yeah,
gets less hot. It's like, I
less
don't know.
exciting. Yeah.
Yeah, it's
I
not
mean,
that
it
interesting.
it actually it could be interesting if it's like, well, by getting it really hot, I slowed down the external computer and used up resources. Right now,
Yeah.
I'm
Yeah.
doing Stuxnet via Doom on, you know
Yeah.
what I
Yeah.
mean?
Yeah.
But
Yeah. 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 Well,
But yeah, that is it is
actually,
often ignored.
and so I don't come off as a naysayer. I think there is a better mathematical proof that is very rigorous and very legit and very well tested by math and society. That's better than Turing complete, and I think it's Doom complete. I think when a system can run Doom is the beginning of it being interesting, not the middle or the end. It's just the beginning, and like computationally interesting. And I said this to someone, and anyway, they said like I was talking to two people who are friends of mine about this, and one of them knows a lot about Doom and one doesn't. And the one that doesn't said, "Yeah, but that's not actually that cool because I see your hand and I'll tell you, I'll give you 1 second." So they said, that's not actually that interesting because you could just make an ASIC. You could make like they have those machines that just can like do Bitcoin mining, but they can't do anything else. It's like you could make an ASIC like a specialized computer that only runs Doom and doesn't know how to do anything else. And then like now you've just made a Doom computer. It's not that cool. And the person who knows Doom a lot was like, "Oh, you must not be aware. The Doom engine itself, like the game, like the thing you play, is itself known to be Turing complete. There's some way that you can set up a map so that you can create little NAND gates and build a Turing machine inside the game as a player of the game. So actually, being Doom complete is the more rigorous mathematical proof, is more interesting. Okay, Anand, yeah, tell me.
I mean, if you say Doom complete, then you still run into the same issue, right? Like, I can create a system that runs Doom, but it runs insanely slow, that it requires infinite time to do something, right? So, it is effectively the same issue as the
Right, right,
Turing
right.
completeness.
Okay, so this is good clarification. So this is a core motivation for me. Like my definition of runs Doom, I should give you my definition. My definition is it can render the first frame of Doom in a human lifetime. That's like what I would say runs Doom means. Actually, a lot of people complain. Like there were some complaints when I launched this video about this project, and people were like, "How come there's no gameplay?" And it's like because like it doesn't. I don't care about games. This is like a mathematical proof. 1 frame is equally as interesting as 1,000. Like if I did 100 frames, someone could say, "How come there's not 101?" It's like it doesn't it's kind of like besides the point. The point was booting the game. So to boot the game, so just to give you like an overview, like, so what am I up against trying to accomplish a thing like this, right? Well, number one, there's a lot of assets that need to be loaded into memory. And so there's like assets for textures and like how the actual game looks on the screen. I know I'm not showing it, but and this is just ASCII art, but hopefully some of you have seen the game before. But if you haven't, just search Doom 1 in your browser right now and you'll see images of the game. So there's game logic, there's state logic, there's state machines all over the place. Doom is actually famous for some of its little tricks that it had. So instead of, cosine and tangent were very expensive, considered very expensive on the computers that these were run on. And so what they did was they had lookup tables where they just pre-computed like, the value, like the precision of cosine and tangent lookups that they would need in the game, and then just printed that into the source code. And so there's like multi-thousand item arrays that just contain lookup values for tangent values. They famously also didn't use floating point, so I didn't have to implement the floating point spec to make this all work, which would have been, I would have done it, like I would have done it. Let's be honest, but it would have sucked, and I was really excited to find a way to not do it. One tidbit I'll share, you're all nerds and computer scientists, I think is really interesting. Think about the player. Okay, now I am gonna just show you the game. Doom 1. So like, let's see a screenshot from the game. Okay, so think about the player in this, not in this article, but let's just get an image going. Okay, so think about if you're building this game, and I tell you a constraint for this game is no floating point because floating point has overhead. The C has a runtime. I don't know. I fight with people about this, and I don't know why it's like an item to fight about. C has a runtime. I think people are very uncomfortable to learn that C has a runtime. C has a runtime. I don't know. Deal with it. It's a very light runtime, and a lot of what it does is handle floating point math and other things. But what happens is in the game, consider that like you have your guy and then he's got I love that I have a swivel chair. I can show you a great demo of this. Like imagine that your character is moving around like this, right? how would you code that? Like, how would think about it for a second? Like, how would you write that if I tell you you can't have floating point numbers? Like, how do you do like degrees? And then it's like you have like you just like do like the bounds of some number is 1 to 360, and then like then you have to do like a check when it from like 360 to 1 because you don't like 361 degrees would be like a nonsensical measurement. And then how do you calculate radians from that? It's kind of weird, right? What they do in the game, and I think it's really cool, is imagine you have the let's see if I have anything embarrassing in Excalibur. I don't. Okay, congratulations me. So imagine that you have a range from like from 0 on one side to 360. 360. All right. And then we're going to just say, you know what? Let's take the entire range of unsigned 32-bit integers. So that also starts at 0. Okay, but it ends at, 2 to the 35, which is like somebody or 2 to the 36, or sorry, 32 rather. I'm thinking of 2 to the 35. In JavaScript, 2 to the 35 is the a max safe in anyway, it doesn't matter. It's 2 to the 52. Doesn't matter. But imagine that I tell you, hey, so we're just going to like map these values on this continuum one to each other. So, this value here is like 2 billion, 2 billion, 400 million something. And then we can divide to get like a number of items per, we're kind of just like smearing over this range. But you know what's cool? In C, if you overflow a number, it's totally fine, right? It doesn't mind. So we'll just depend on the overflow behavior. And when you wrap around, so like let's say that this pointing directly straight at you is 0, and then that means a little bit to the other side, counterclockwise would be like 365, or I'm sorry, 359, let's say. If I add 1 and I just come off of this range, whatever that 2 to the 32 value is, then you wrap around to 0. And so we're just like exploiting C's behavior in this case. And that's how they get around. So there's a few times in the code base where they do tricks like this to get around building more complex, like computationally complex paradigms like floating point arithmetic. So it's interesting. But anyway, all this stuff needs to be encodable in TypeScript types. And it's very complicated to do something like that, right? So I thought that it wouldn't be possible. And so what I did though is I created a test suite, and I started doing like basic 1+1, some sort of basic math like you saw us do. And my first prototype for this was here. I'll just go to the bottom of this screen because we have TypeScript in here. My first prototype idea for this is like, well, think about it. Doom is a deterministic system, right? So there's no outside influence that it needs to run the game. It doesn't need the internet. It doesn't need disk access because you could think of it doing everything in memory. Like you could abstract away everything to a point where it doesn't need to know what time it is. You could just tell it the time is 0. Just tell it it's 1970 or whatever the Unix epoch time is, and it's gonna still run. So it doesn't really need anything. You can push all of this stuff. This file was not auto-generated, actually. But anyway, the AI really thinks it knows. So what you can do is you can just unwrap every loop. So you can think about like if you have a loop if you have a for loop over some values, right? You can think of yourself like taking all of the let's just say you have a for loop over I, right? You could think of this in a way where you're like, you know what? I'm gonna like unwrap this. So instead of 100, let's just say 5. So what this is basically going to do is this is like, I know the first time through, I'm going to skip ahead because you all are computer scientists of sorts. So I think I can say this faster for you. I could like arrive at a point where I guess it'd be that, I don't know, whatever it is. I could arrive at a point where actually I take this kind of code as an input and I output code that looks like this, where there are no loops, where I just kind of like expand it. And then like if you think of there being another loop inside, like if you put another loop inside here, um, then you could do the same thing. You could just kind of unwind every loop. It's a deterministic system. So like why can't you just unwind every loop? And I started doing this process where I was trying to understand how to work with the C code to just get it to compile in such a way that I could kind of decompose it into its smallest parts. And then like if there's a loop that loops 1,000 times, that's fine. I'll just have 1,000 of the same items all over and over again. What's the big deal? It's not a popularity contest. So And then yeah, I mean here we would say it wouldn't be I, it would be J, but hopefully you get the gist of what I'm saying. You would have substructure then underneath here, right? You would have if you put a J in there, you would have another for every one of those, you would have more, and it would get to be a lot, right? But if it's just compiled output, who gives a damn? Well, what happened with this approach is it just doesn't work. It's just a lot of code. It is like it would be like many petabytes of code to unwind every loop because you have to think about like there are at the time it was about 80 million instructions. If you compile the code to the Doom C code to WASM to kind of get a feel for how much like what's the girth like how big is this? It's like 80 million instructions, and WebAssembly has loop instructions, and so like how do you even encode that in a file that could be processed by JavaScript or any, because, TypeScript is built in Node. So I have to confide to these kind of barriers. And it was then I realized I'm going to have to do something a little bit more exciting. And so somebody suggested to me, why don't you do a Clang compiler target? I didn't know what Clang was, and I know what a compiler is, I think, kind of. I know what a compiler does, but I don't know how they work. And I don't know what a target is in this case. So I could kind of piece together what that meant. But I was thinking about it and I thought, I'll take a look at WebAssembly. So WebAssembly has, let's see, oops, I closed it. No, I closed it. I'll bring it back. WebAssembly has uh, these really cool properties that make it fun for this kind of a project. One of them is that you can do kind of like arbitrary inputs, like you can compile C to WebAssembly, and it comes out with like a fairly small number of outputs. Someone told me later, Dimitri, why didn't you just target assembly? I mean, assembly would have been even easier than WebAssembly. And the answer is I didn't think of it. I don't know. I just didn't. I didn't think of it. I didn't think of much. So I'm going to show you a very simple WebAssembly program. I32 from my test suite, in fact. So if we go to I32 add, we're going to look at here. And this is what WebAssembly looks like. It's kind of a lie because actually this is what WebAssembly looks like. Oh, it won't load it. What? Come on, you loser. All right. Anyway, WebAssembly is a binary format, so I was going to show you a bunch of bytes. Yaka yaka. But WebAssembly itself is kind of a Lispy. Do you see the mapping? Like I mentioned in the beginning, like WebAssembly or TypeScript's type system is kind of like a functional programming language. There's only expressions, no statements. There's only recursion. It's like everything is immutable. There's no mutate. You can't like mutate a type. You can return a new type from a function, right? And that's why there's only recursion. And that's kind of similar to how WebAssembly works. WebAssembly is very simple and just gives you kind of like a list of instructions that you fire off, and you're just expected to sort of do them. I can show you like slightly more complicated one. I think we can jump ahead multiple returns. Let's do this one. Or actually the Anderst one was good. Yeah, that's fine. This is from C. So let's look at like what it looks like to, I'm going to show you the full kind of flow here for a second. So I wrote a C program here, right? Or like let's do this. Let's do this. We're gonna go really deep because you guys know what you're talking about, I think. So this is a C program that I wrote. This is the first C program I had ever written. I was very afraid to write C. So I've been a professional engineer like for, I don't know, 15 years now, 12 years, something like that. Depends how you count it. I've been paid to write software for a long time. Some of it was in school, so I don't count that. But even though I didn't get a computer science degree, I was doing projects for people and helping out in different departments and things. But I've avoided C this whole time because I'm not good enough for that, I think, has been my attitude. But in this project, I had no choice. So I figured out dimly, I don't know if this is good or not, C code, but I figured out how to write Conway's Game of Life in C with no dependencies, including no libc. You see, there's no libc here. This is just like completely kind of, I don't know, raw, so to speak. And you make a grid state. It kind of looks a little similar to the thing you saw in TypeScript types before. Then what happens is you can compile that to WebAssembly. So this is what it looks like when you compile that stuff to WebAssembly. And it really bears very little resemblance, I think. Like you can see there's the function names were preserved. We want Conway.c. So the function names are preserved. See, we have this function called count alive neighbors. And so there's like this stuff in here for count alive neighbors. We have this other one, update grid. Okay, there's like more stuff for update grid. But in
Ju-
general, like,
Just to be clear, you're not actually editing this hellish WebAssembly code, right? You're generating this, but you're never like getting in the weeds of like this is unreadable.
no, I'm always in the weeds of this. Yeah, this is this was generated by compiling it
Yeah.
but yeah, the vast majority of this WebAssembly in this project I wrote by hand. So like this was a simple one that I wrote by hand, but there are much more
Hmm.
complicated ones that I
Things that
wrote
look
by
like
hand.
this thing on the right.
Yeah, exactly. Yep. And I had to learn what everything is. Like I had to go. I actually did it with Conways. Like I had to go piece by piece and figure out what is local L3. So there's L3, L4. What is all this shit? What is
Dimitri,
this?
this is insane. My PhD was in theorem proving in Lisp, and I like would not want to touch this. Like this is
Oh,
like
yeah.
ungodly
Someone made
complicated
that joke to
looking.
me that like, it's a shame you didn't get your PhD off of this.
Yeah, you should have. Yeah.
Is it too late? I don't know. You tell me. Uh, so yeah, I mean, I think ignorance goes a long way, and it's not just ignorance, but like I think I've been mostly just like not. We're here to talk about technical stuff, but it maybe is important for you to hear. Like, I think I've like mostly been a failure most of my life, or I've been told I was a failure a lot, and I think it put me in a state of mind that I don't really care a lot about hard problems don't phase me much, and so like this happened to me a lot. This is like the worst example in my life, but it's happened to me a lot of other times that someone said like, how did you like survive in that fucking shit code? Like that was terrible. It's like the worst thing ever. And it's like, I don't know. I guess I just have a high pain tolerance or I have a low bar or low expectations. But I never really saw this and got too afraid. Like I was like, okay, well, I'll just figure out what it does. And that's always been the way I looked at it. So yeah, I mean, I had to go through and like piece by piece understand exactly. And so actually what some of it is just like, so you see, if you go to the bottom, there's these globals. So WebAssembly has global like module level variables that can change at any point in the function. And this was the biggest reason why I realized my original approach I was telling you about unwinding every loop could never work. Because what you would need to do is duplicate the entire state of the universe up until that point to handle what a global variable was set to. And then like now you're starting to get into computation and I don't want to do any pre-computation. I can pre-compile, but I don't want to like run anything because these global module level variables that can just change. You see this right here in line 380, global set G0. Okay, let's just talk about this really quick. Okay, all this is saying is there's a local called L1. So get that local. A local is a state that's stored within a function execution context. And then there's this constant. The value of that constant is 96. Okay, then we're going to add those things together. And whatever the result of that is, we're going to set that equal to global G0. Okay, and this is happening. This is like a stack counter. So there's like some error handling stuff that gets compiled in. And anyway, this is so that you can find where an error happened. But this is this is just how the world that you have to live in. And I had to kind of understand how this works and I had to work with it a lot. So eventually, you can do kind of computations on the stuff and get like, you can see there's like a syntax like I32 dot local dot. So you can like grep the file and see all the things. And so for a while, I don't, oh, I got rid of it. Okay. When the night before I launched the project, I got rid of it, but I did have like a table of all of the instructions I would need to implement and like where they were at, like how close was I? And these were all the instructions that I had to write by hand. And again, this isn't a world. I want to like we're time flies so much on this. And I know we have 15 minutes, so I'm gonna try to go even faster. But basically, if we want to talk about add, like we have this add function. I'm gonna open a bunch of files on the screen at once here. So we have this add, and then there's this binary. Why can't it show the binary? Come on, you fucking stop. It's cool to see the binary, but anyway, whatever. We have this add function that is written first in WebAssembly. Or actually, I have add in C. So let's do add in C. So we have add written in C, okay? Then we compile that to WebAssembly. Boom. This is what that same thing looks like in WebAssembly. And it's really not, you can see there is that, like the call CTORs and there's some stack heap baloney, whatever. But, look here. This is really the meat and potatoes of it, right? It's like it has an add function. It gets these two locals. This is a function. A local is a parameter passed to the function by nature of the fact that it's like this param p0, whatever. Don't worry about the syntax, but this is what's happening, right? Then I have a I have a Rust program. I often don't. You guys are getting the special sauce here. I often don't tell people about this part because I've learned by giving this demo a lot of times that people get very distracted when I say there's Rust here. Yeah, there is a. I even pushed it all into one file so that I could hide a little bit from the world. I don't want people getting like confused about what role Rust plays in this. Rust doesn't do any work. I just like Rust. Rust is great. Rust is awesome. TypeScript, boo. Rust, yes. And what happens is it takes this text. Okay, so this text is created from the binary. So we go from the binary. This is like a human readable version of the WebAssembly, and then it creates this c.add.ts. Now this let's make these kind of closer to each other. You can see that this looks very similar, actually. It's just kind of like a string interpolation version of the same thing. But this is syntax that TypeScript can understand. And so what happens is I took the C call, whatever. This is entry. So this is our entry function. I made a convention. There's so much to talk about here, but like somebody on Twitter when this project was announced, a lot of people didn't understand what this project was. And they say like, this guy may have like written a lot of this in TypeScript, but he didn't write it all in TypeScript types. There's some JavaScript somewhere that does work, because otherwise, how would you run it? And it's funny because like I had the same reaction. I thought the same thing, that like, yeah, but like even if I do get really far with this, how am I going to be able to actually run anything? And it turns out that like in C, a main function, like someone said like, but where's your main function? And I was like, you know what's funny? A main function is just an abstraction. It's just an abstraction. It is the lowest level abstraction that you can't get past in like a language like C. But it is actually an abstraction. Like beneath main, there is stuff going on. There's like a underscore underscore start, and there's all these conventions. There's like the elf format and whatever. It goes deep, but there's all this stuff beneath it that are kind of like givens. And when I say given, I want you to think about like we have things that we know about like ASCII encoding, right? And we have these things that we take for granted, but it's all just bullshit, right? So it's like we know that because of the rules of ASCII, like the value 48, like the binary value 48, the number 48 maps to 0. Okay, and the number 65 maps to capital A, and 66 maps to capital B. And so we do these things where we send bytes over the wire. We do this with that's all of the internet works this way, right? We send these bytes, but we expect that the other side of the fence knows in advance that, hey, 65 means A and 66 means B, and they have these binary values, whatever it is. But this is like a convention. This is like breaks polymorphism or whatever. It breaks the, or breaks monomorphism. We're saying that, hey, there's this other side of the fence that has knowledge that we didn't give it. And these are these conventions. And so like there's lots of these conventions that exist. And this way was the way I was able to. So there is actually a bootstrap function. So like there's a thing that has to happen to bootstrap the program. And I'm going to walk you through that in just a second. But basically what we do is we compile this text with Rust to something like this. I don't do any work. Now you all understand I don't do any work, but I've learned when I show this to people, they're like, well, what does the Rust do? And it's like, it doesn't do anything. I could have written it in Bash. I could have written it in any language. It's just taking strings. I like Rust, so I did it to make it less miserable to work on this. But you can see here that really it's pretty similar what it's doing, right? So with this entry function here, it's a func. So there's that piece of syntax. There's this piece of syntax here, $entry. It has the export. Don't worry about the export. It has these types of T1. T1 actually maps to this thing. WebAssembly has global types that you can define to save space and stuff. So okay, so we have this type. And so we see that we have like param types, I32, and a result type. It actually also has a result type here, which it has this is the T1. It has params, P0 and P1. And look, we have here P0 and P1. And then it has this body where it has this add. This is reversed. There's a thing called folding and unfolding where you can show things in like a folded manner or an unfolded manner, meaning like the way the parentheses work out. But you could think of you could think of it both directions. But it was implemented without folding. But it's kind of like the instruction. You get P0, you get P1, and then you call this add instruction. And what happens when you get a value is actually you're pushing it to a stack of the function execution context, and then so you're going to like push a value for that first for line 21 here. You're going to push another value for line 22. And then the way the instructions work is they just pull values off of the stack and do some arbitrary bit of work. So they'll just, in this case of add, obviously it's going to pull two numbers, going to pop two numbers off the stack. It's going to do some work and it's going to push one back on. And so then we know that the result type of this is it's going to leave the stack. It's going to leave the execution context with one value when it was loaded with two. And that's actually how you pass parameters to functions as well. You just push values onto the stack before you call the function. And then when the function awakens, those values, it just assumes that those values are there. I implemented this with something called a global stack, and I didn't know until much later that there's an error called a stack underflow that can sometimes happen. I don't have time to show you, I think, but yeah, if you accidentally create a situation where a function can pull values out of the stack beyond what it should have been able to ever access, then you get into like corruption errors. You need to do some stuff to say, hey, function, listen now. You can only grab this many things off the stack and no more. So don't even think about it. And so I had to put that in. But moral of the story, we get into this situation where we build up these bigger and bigger pieces. And the logic still has to be implemented in TypeScript, right? So I want to show you the add instruction here. This is, let's see, where is it? This is the add instruction. And you see this stuff about reversed. There's so much to say. I just see it's like I just got warmed up. But in the end, I'm doing all of this with binary strings. So if I show you the test suite, I have to show you the test suite. But uh, in the end, I'm doing tests with these like long binary values, right? And so like let's go here. So I have like A binary and B binary, and then like this is the decimal result of calling add. Sorry, this is the decimal result of calling add on those two numbers. This is the subtract, multiply, divide, and so this uses two's complement binary. That's how WebAssembly is, and in two's complement I didn't even know what two's complement. I thought to make a number negative, you just make the left bit 1, and that is a way of doing negative binary numbers. It's called signed magnitude, but there's this other thing called two's complement, which has a lot of niceties. But the problem is, and I actually tried really hard to make this work, but I realized, and I left it in the code because I knew I would tell someone about it someday, that like I tried to implement the math from left to right. So that is to say the least significant bit or whatever. I don't know. I'm not a computer scientist, but anyway, with the left side of the number to the right side of the number binary. But what happens is you need an arbitrarily large window that you could need to grow to handle a carry from the future because, and I explain it here. This is all open source if you want to read it, but like I kind of give an example that, like why it doesn't work. This is a problem because in TypeScript, I don't have time to show you, but there's a silly limitation. It's just they made a choice at one point about how you can iterate through the characters of a string, and you can only iterate characters of a string from the left. There's no other way to do it. It is built into the compiler. It's just an implementation detail, which means that for all of the math that I need to do, I have to do all of the algorithms in reverse. And this isn't, the end of the world. None of the things that I'm, in this project were really the end of the world. There's really just one thing, and you can watch it. I released a whole video on just like there was one. This whole problem was like 1,000, 8 out of 10 and 7 out of 10 difficulty issues, and then there was like one 12 out of 10 problem that I hit. And it's very specific, and it involved like basically changing my DNA and reworking who I am as a person. And I feel like, I don't know, I feel like it was my come to Jesus moment on this project in a way because I just like I felt like, okay, this is nothing I will ever do in my rest of my career will be harder, and I'm expecting that to hold. But so watch the video on that and what that's about. But like here's an example with like division sucked. Division was very difficult and remainder, but the division and remainder come out of the same algorithm. I had to learn a lot about like how there's this these various algorithms for doing division and like how they work, and I had to really break it down. And so there's actually a division playground where in order to get division to work, like you can think of division as having like the algorithm as having steps that it takes, and that you saw in that last screen that there are like I took note of all these various steps that you do to kind of like make the algorithm work. I busted it out into like every single step, and I did it at every single number of bits. So this is like with 4 bits, and this is like checking that like, oh, if you have an accumulator and a quotient with these values, and like you're just doing bit fiddling. And I did that more and more, and so I just added to just see where it breaks. So we're just now you can see kind of like from a big distance the numbers are getting bigger and bigger and bigger and bigger until you get to a point where you're dealing with 64-bit numbers um, to make sure that it all works. So yeah, in the end, this is kind of the process that you have to go through. So the test suite. Okay, we have time. I'll show you the test suite. So how do you make a thing like this not fail? And so the thing I was telling you about that was like the hardest problem, the 12 out of 10, was the problem that I knew I would hit is that if it needs to really work the first time I run it, like it has to work because there's no way to like debug this at all. There's like you are completely blind. It can fail or it cannot, and it can run for 30 days or can run for 60 days. And I had ways of estimating how long it might take to run. But ultimately, like there's not a lot of visibility. It's like all binary. It's like if I gave you machine code and said, here, debug this. It's like, I mean, you probably could, but it might take years. So I had to have a very extensive test suite all the way through from beginning to end. And so what I did was I built I built these inputs. You see this on the left for all these different test cases. So like these are test cases for 32-bit integers, but there are more. You see on the left here, there's all these different, like maybe it's more impressive to show you the 64-bit ones because like 64 bits is a lot of fucking bits. You don't think about it until you're in the middle of it, but like it is a lot. So we basically take these numbers and I run them 4 times. So the first time that I run them is in the let's see, let's do this. So I write a program. I'll just tell you the first 4 and then we'll talk about the last 2 because they're the most interesting. I write a program in just purely in TypeScript types that runs that says take this input A and take this other input B and then run some pre-computed calculation and then we're going to get this value out. And so just assert that those values are exactly equal. Then I do it again with decimal numbers. I have a routine that knows how to, in TypeScript types, that knows how to convert values from decimal and binary. That's 2. 3 is I do that same business again, but in pure JavaScript. So there is JavaScript there in the test suite, making sure that I did the things that are right. And 4 is doing it again in decimal in JavaScript. Turns out that the way the JavaScript handles binary numbers is actually not compatible with the way that fixed width 2's complement numbers work. Okay, but the the 5th and 6th example, and actually for C, there's 7 and 8, but let's just say the 5th and 6th example of the test suite is running it. Number 5 is right here in front of us. So we're actually like literally going, see this is the file arithmetic that we were in, right? So I'm grabbing T, the lowercase t and uppercase T. So one of them is a type. You can see here, I'll make it a little bigger. One of them is, and one of them is an array of values. In TypeScript, you can get literal values out of the arrays like we were doing before with the red and green and blue. And so what happens is, and I made a lot of them have little launch pads here, little dashboards that I can build for myself. So I could even, like we could go down here to a number. Let's go to 58. So I'm going to go here and I'm going to say 58. And we're going to have this 2/ thing that we were seeing before. It should update in a moment and show us those values that we're looking for from this particular add function. There it is. It's a little slow, but that's life. And so it's showing me like this is the test suite values. And so then what I did is I ran it against so this function here, get wasm, is the JavaScript WebAssembly runtime. And so that way I was able to verify that what I'm actually, the inputs and outputs of my functions, of my instructions, you have those 116 or whatever instructions that I had to implement, that they actually directly map to the real value that you would get if you ran this WebAssembly program with a pre-established WebAssembly runtime. And this is like crack cocaine to a reverse engineering project because you have the answer. You have another system that will tell you the answer, and it's like your little oracle, and you can just take another hit and get the information you need. You don't have to fuddle around. And this made a big difference in the project because there were tons of things that I wasn't unknown unknowns, things I didn't understand about how in JavaScript, if you do 32-bit arithmetic, it does it in a 32-bit register. And so when you get very close to the 32-bit limit, it will start chopping the implements, the kind of temporary values. But in WebAssembly, even if you use 32-bit numbers, it does multiplication with a 64-bit register and a 64-bit architecture, which is where I was running this and benchmarking against, and it will only chop at the very end. And so you get different values. So I would have 150 test cases, and then like 4 of them fail for multiplication. And it's like, how could 4 of them fail? Like I would expect 90 of them failing, but like, and that's how. So I learned a lot by doing this, and this was like the way that I made sure, because the 6th and most important one is this thing, entry. Entry is literally just this thing that we looked at before, that the bootstrapped program that is initialized and run and ready to go and having all those memory values. All right, I ran out of time. What can I can keep talking for as long as you guys are interested, but that's the
Dimitri, I've 100% seen PhD defenses that are like both less work and less intellectually rigorous than this project.
So what do I do? Do I call up a degree granting program and say, hey, can I have one? I mean, what's the process?
I mean, you could give it a shot. This is completely unhinged.
Thank
Why
you.
did you manually write so many lines instead of like using
Okay,
list
yes. Right,
comprehension?
right, right. This you asked a question someone from the TypeScript team also asked me because there is a mapping syntax and
Yeah.
I could have just done it. What happens is like let's change a number here. Let's do that. So eventually, again, these things you need patience to work on a project like this. I also removed a lot of the guardrails within TypeScript. So TypeScript does have some like built-in recursion limits and things. Um, and while I was working on it, I removed them. I put them back at the end. It does run with vanilla TypeScript, but I needed to like be able to do dangerous things. It's just so that I can tell which test case is failing because it just works out such that if you did it with the mapping syntax, it tells you that the types don't match, but there's really no way to tell which one fails. So this way I get a line that tells me which one fails. That's it.
Got it. That makes sense.
Yeah. But again, I have time. I can do. There's a lot more to that. This truly is like a. This is a good warm up for me though because think something I haven't done yet is similar to what this call is like, is to do like a 3 hour, maybe 4 hour, depends on how my voice gets through, like soup to nuts, like beginning to end rundown of how the internals of this all goes. We didn't even talk about memory. So like, if I go to Doom, uh, um, if I show you like how memory values actually work, the memory is contained in a large object, and it's just it's literally just like where the multi 100,000 line object by the end of like the memory address and the byte value at that address. And so if you think of storing a number, you're going to need what's selected here on the screen. You're going to need that much stuff to store the number 1 or to store the value true. You need that much. So that's why it becomes, in the video I explain it's 177 terabytes of if you add it all up in the end. The truth is it's actually probably quite a lot more than that, but it was done in memory and then I had a process by which it would dump to the we can see actually some of it. So like here's some of the temporary dumps. So like here's what I could get. Syntax highlighting kind of barely works sometimes. It's a bit much for a little computer to manage. But like this is like kind of what's in there. We can see some you have to handle branching, you have to handle like when you call you're like if the WebAssembly calls a function, it has to be able to store the context of the function that it had before and then push it out into a new thing. So you have to, when you return from a function that called you need to be able to resume context from that point and then like restore all the globals that were there or whatever. Well, they're not globals, but the locals for that function at that time. So I think I can maybe I can show like the core the core program itself. This is in the video, but it has the announcement video anyway. But like this is like the meat of the machine. So like the state machine has this is a number, but that's the only thing that's a number. The rest of these are just strings, like binary strings. So we have a stack, we have a kind of, this is like these three things consist of an execution context, and I, for performance reasons, hoist the active execution context to the root of the program because most of the time that's what you're dealing with. This is like a list of instructions. You have to keep track of all the branches that the code has gone down in the past because you might need to resume them. That's actually also there's a garbage collector here, if you can see at the bottom, and that's one of the tasks that the garbage collector will do. It's configurable, so every like 1,000 instructions, it will wake up and then look through the branches and see what it can prune, and it will prune branches that should be unreachable. And there's a way that I was able to kind of prove inside the program that it's unreachable for the garbage collector to do that. Otherwise, you end up storing all of the functions that you've ever called in the past, and you can't get rid of them, and you can't, push them aside. There's L1 cache. I had to do memory cache. So in TypeScript, it's just very slow to insert when you get an object that's hundreds of thousands of line long. It's made for objects that are 10, 20 odd, items long. The fact that you can get into 1,000 is bizarre, and the fact that you can get into hundreds of thousands is like unheard of. So I had to implement a read cache in front of that so that when I want to set a memory value, I'll actually first set it in the cache. And that's another thing the garbage collector takes care of is it will consolidate the L1 cache and kind of refresh it so that when we're working in like daily living, we're just setting on this like quite smaller, you can see it's the same type as the big linear memory. Yeah, but I didn't know any of I didn't know any of this stuff. I didn't know execution context, garbage. I've heard the word garbage collector, people complaining about them, but you know, I I joke sometimes that I can keep going as long as you want, but I joke sometimes that you have a 50-50 shot when you implement a thing like this of doing it big endian or little endian. And just out of ignorance, I did it big endian. And I got very far into the system where, it turns out that if you are only dealing with four full bytes and you store everything in reverse in memory and you read everything back in reverse in memory, you can do it backwards because like mathematically that works out. But the problem is you start hitting these memory addresses like here's a let's find one. Here's like I32 load 8s. Okay, so what this instruction is saying is you have an I32, which is 32 bits, but they're 8 bytes or 8 bits per byte. So you have 4 bytes, and it's saying, hey, look, take just the smallest 4 bytes. Take I guess it'd be the rightmost 4 bytes, and make that a new number. And if the left bit of that is a one, then push ones, like make it a negative number. So this is a signed load 8, but discard the other 3. So now you're starting to take like a portion of a word, a portion of a 32-bit number. You're just taking the first 8. But then like that word first is where the problem comes. So it's like, oh, now it suddenly matters a lot, like which one is first. Because if you store them in reverse, now it really matters. You'd have to do that in reverse. And so I fixed it and I found the test suite, and I found it by doing that test case that I showed you where I was running it against the JavaScript runtime and I was able to validate the actual values. And actually, all I needed to do to change this entire system, like everything about it from big endian to little endian, was change the order that it's reading these, like that it's pulling things out here in these 2 lines. That flips the whole system from big to little endian, because this collect bytes thing is a common routine that everything used. But I didn't know anything about all this stuff. And after I fixed it, this happened so many times to me that after I fixed it, I would go like, wait a second, is that what wait a second, is that what endianness is? And then I would Google it and be like, son of a bitch, that's what endianness is. Okay, but now I know what endianness is. I'll never forget for the rest of my life, because I like really, you learn by bleeding in situations like this. So there were lots and lots of stuff like this where I had no clue what I was getting myself into, but I figured it out as I went along, and I never thought it would work. I mean, so maybe tying the conversation in a loop, I'd love to take questions and stuff, but tying the whole talk here in a bow, I would never have tried to do this if I knew what it would take, ever. If I was case in point with the PhD joke, like if I was in school, I would never have selected this as a candidate project, because it just doesn't seem like something that could be done. And I always had that attitude. I never lost faith throughout this entire project. So I worked very hard on this. I worked for like basically a year and a half in total. And there was about 3 months of that I was unemployed. And there was maybe, 6 or 8 months of that I was working contract, so that I could work like just a few days per week in order to spend the rest working on this. There were many 18-hour, 20-hour, 24-hour days where, I'd see the sun in my window here go up and go down and go up and go down again. And then I'd go like, oh, I should stand up. But the reason I kept going is because I was constantly sure that I was getting to the end. I was constantly sure, like my wife would ask me how close, supportively, she'd say like, how close are you to the end of this? And I'd be like, bro, it could be one day, could be, it could be 10 years. There's no way for me to know, but I feel like I'm close. And that was always what I felt. But I never lost faith that it would not be possible until the very day that I got that frame that I enshrined here into the code base, until I hovered over a type and this came out. And it was clear that I had done it, and I can't deny it. And I just have to live with the fact that it is possible. I just feel like it shouldn't be. I can't really shake that feeling even now after it's done. But yeah, I mean, if I had made a plan, it would never have happened, because I didn't know enough. I didn't know what little Indianness and like garbage collectors, and I can do some shit. Okay, I'm smart, whatever. I'm hardworking, but like I just didn't have the skills. I'd never written C. I didn't know what LLVM was. I'd never worked with compiler stuff. And there's so many parts of this that, we didn't even open the C code base, but like working with compiling the C was like I took like 4 months of it, was just figuring out how to compile the C in such a way that it doesn't have any dependencies like we were talking about, because it's not really straightforward to do that. Like compiling out libc, for example, like I can't have libc in there because libc has floating point, libc has all kinds of shit in there I don't want and don't need, and it's just going to make it a lot harder. So yeah, I think I was not expecting to be preaching this, but my takeaway that I hope people have from this project and hearing about it is partly that like there are some projects that don't benefit from plans. There are some projects that benefit from just blotting out the sun and putting one step in front, putting one foot in front of the other every day, and just, I broke it down into very small pieces that I knew like, okay, well, today I need to do this. Tomorrow I need to do that. Tomorrow I need to, the day after tomorrow, I probably might need to do this. But I didn't go a lot farther than like a week ahead because I never thought it was going to happen. I always thought it was just like going to be over one of the, like the pain will stop and I'll just be done with this project and I can move on and I can make a video showing why it can't be done. And then maybe some other nerd who doesn't agree will take it on. But I never thought I would take it to the finish line. And I didn't want to take it to the finish line either, which is also why I haven't, like, I will never touch this project again. I have no emotional, despite spending so much of my life on it. And it's a big accomplishment for me and I'm very proud of it. I will never touch this code base again. I don't care. I don't like it. I don't want it. It's just, it had to be made, so I made it. But, that's kind of how it goes. So anyway, yeah, that's an overview in any case.
Dimitri, are you familiar with the concept of a weird machine?
No, what's that? Can I Google it? Will it show me?
Yeah, totally. So, this is something I think a decent number of people on this call know about, but weird machine is a concept that's like when something is Turing complete or otherwise powerful in a way you
Mm-hmm.
did not anticipate it being. And this is something that people study academically in a security context. Like, if I remember correctly, Prashant's an expert on this. He can correct me if I get it wrong. But I think like the BSD send mail routine had like some sort of header format that turned out to be Turing complete, and you could just like execute arbitrary code on somebody's
Mm.
computer by like sending a certain elaborate email. Anyway, this is definitely an example of like a weird machine. It might not be a very useful one. I mean, I
Yeah.
don't know. Maybe again, maybe the next Stuxnet will be
With
work, but
there's a way. My mom would always ask me that, like, can you sell this? Is there a way you can make money from this? And I'm like, no, definitely not. It's not. I don't I mean maybe. I haven't thought of it. I'm gonna make it open source. So if there is, I guess I missed my opportunity because it's MIT licensed. But you know, um, we do these things not what's the joke like see I'm gonna screw it up, but not because I don't know, because we thought they'd be hard, because we thought they'd be easy. I thought it would be
right.
easy. I really believed it would be easy. And um, you know, I said I was unemployed. I was unemployed because I got fired. I got laid off, I don't know, laid off or fired. They never tell these days when you when you leave. For those of you who haven't had jobs in industry, they don't tell you these days because they're afraid of getting sued. So you never hear the word laid off or fired. You just hear we think it's best to move on. So I was very crushed by that, and actually a lot of people were let go from that company at the same moment. So I guess that means I was laid off. I don't really know. They didn't tell me why. They never gave me a reason, and I was very prepared to stop doing programming forever.
Mm.
I have other things. I have a woodworking business. I do CNC manufacturing, and I could make money doing that, and as a replacement income as a software engineer. Like, I'm not really that gung. I've never seen myself as a software engineer, and it's actually dangerous to be a software engineer professionally because this is what I do as a hobby. This is what I love. And it's the same danger that artists sometimes find themselves getting burned out, where they love art their whole life and then they become professional artists, and then someone tells them to make some stupid fucking thing over and over again and they lose the love. And it can change you emotionally a lot if you get into that situation. And I'm worried about that. So I was gonna just move on and do different things, and some stuff happened, and it just was clear that it wasn't time for me and my family to do that. And I thought, okay, let me do a little like quick 2 week project to kind of like rekindle the friendship with the keyboard, so to speak. Like let me come up with something that's just for fun. And this was it. And I thought I'll just try this and see what happens. And I guess I just never stopped. I don't really know how to stop. It's a kind of character flaw. Sounds good when I can show you that this thing was successful, but boy, there are dozens and dozens of projects behind me that I tried really hard on that I did not succeed. And you know, um, this is just the one that people get to hear about. But yeah, I've been fucked many times by my intuitions. Let's see. Oh, there's
Dimitri,
comments here
this
in
is
the.
completely nuts.
There's comments. I didn't see. I'm sorry, I didn't see the chat. Let's see what's happening in the chat. What's from like an hour ago? Okay. Or no, it isn't. It's from minutes ago. Hello. Hi, everyone. Unmute. Come on. What's up, guys?
Yeah, if anybody has questions, they should speak up now or forever
Yeah,
hold
yeah,
your
yeah.
peace.
Please.
I guess like how specialized is it to Doom? Could you take any other code base that
Zero. Yep. Zero.
like as long as it just doesn't have floating point and you
Yep,
just
floating point is like the biggest gotcha at this moment. But there's other programs like I wrote. I did Pong, for example. I had to do Pong in a really shitty way because like I just wanted to show how I did Pong because I wanted to show how inputs might work. Like I knew people would ask me before it was announced. I knew people would say like, how would you handle keyboard inputs? And there's actually a really obvious way to, I mean, to me anyway, I think it's like fairly obvious way that you would handle keyboard inputs, which was look at this. This is like that repeat function. See this shit? It's like you get to kind of get used to it after a while. You know, you squint. If you do this long enough, you kind of squint and it starts to feel like a programming language. So we have this little repeat function here. Look, we have value to repeat. We have a number of times to repeat it, and we have this accumulator that we're tail call recursing in. And so like this is you know a game of a Pong that I said like for the first 5 frames go down and then do nothing 5 times and then go up 10 times and then go down 10 times. And I wrote this in C, right? So I wrote Pong from scratch in C, which you know, but with no libc. There's no C standard library here. It's just like straight C. Um, and yeah, I mean, it can do this. It can do Conway's Game of Life. Conway's Game of Life was like a benchmark for me as I was going along. That was one of the biggest. So I felt like it was a really big milestone when I finally got Conway's, like the one that I showed you in C, running and working and returning the right result. That happened in January 2023. So I didn't. The final run that Doom worked was in the Halloween, actually, 2023. So you know, it was a long gap between this is a fully functioning, you know, WebAssembly runtime, at least of the instructions that, you know, Conway's needed, which was like 50 instructions out of 116, so a lot. It was a long time between like that and like the thing working in the end. Hmm.
how does your screen buffer work?
Okay. So Doom has a screen buffer, and I end up having to write to it, and yeah, I just let it write to it. So it actually does like a little extra work, right? Because it's taking a lot of the 12 days that it takes. So it runs the TypeScript type checker in a loop for 12 days, like kind of dumping its temporary value. So that's what these result things here are. If you think of it like a stateless functional machine, like this is like a machine state, so it's like a core dump almost. Um, um, what happens is a lot of it is just loading the textures into memory. Like of the 12 days, maybe 9 of it is just loading stuff into memory, which sucks because it's the first thing Doom does when it wakes up. It takes those textures from the game assets file and puts them in memory so that it can spit them out quickly. Because Doom does like ray casting and it does some like physics stuff. And it's very important to me that that's like no cheating in any of that, like no cheating on that. So I achieved that part, but it's really nerve wracking because what happens is it would be like, you know, I was like watching it and then it would be really clear that it infinite looped. And then I would have to like, you know, so there were runs that made it 20 days. I didn't know it was infinite looping. I thought it was still working. And I would have to, during that 20 days, I'm like nervously watching it. I would be like, be here with my pits sweating, stinky, you know, like trying to figure out what it's doing and what's going on. Um, and I would eventually figure it out in every case. So the final run that was successful, I lost. I wish I had kept counting, but I was because I knew I'd make a video and tell people this story. So I kept a log of like the previous runs and like how far they got and where they stopped and all that stuff for the first like 9 runs. And there were some things wrong. There were probably like 4 things that I didn't do right. Um, and then a lot of it was memory and like performance problems where it wasn't anything wrong, but like the L1 cache needed to be made, the garbage collector needed to be made. And the final run that actually succeeded was probably like the 20th run, maybe like 18th run. So it ran there's a lot of failure runs where I was just like, okay, I don't know, whatever, it's just fucking play. I'll come back in 10 days and find out it sucks again. And that was kind of the way it went. Hmm.
Yeah, pretty cool. Is how is the reaction like how is the reaction compared to what you expected?
Um, I think I went overboard probably on a lot of these things. Like, people didn't question as much as I thought. Like, personally, I would be very if so. I was expecting more critiques of it, and there's basically been none. Like, I think the yeah, there's basically been none. Like, I would have to really think for a moment to figure out like complaints. Like, people complain about the video. They're like, how come you didn't show gameplay? Like I said, and it's like, okay, well, you're not the right audience for this video is the answer to that question. Like you don't understand what is significant about this. And so you're wondering like, why can't I see more frames of the game? It's like, I don't really care about those people. I'm happy for them, but they're not like, that's not who I did this for. I didn't do this for anyone really. I think it's been basically exactly what I thought it would be, which is like nothing can top. It's been pretty, I mean, I've had great accolades because of this project and but I know I'm a nerd about this stuff. So I would tell my wife like, um, she would ask me like, is this really worth it? Is this really worth all this time? You're like so absent, this is really hard. I'm really killing myself. My back was I would have, there were a couple videos where I would be like, like that Conway's video. I took a video right when I was so happy when it happened. I went like, yes. And as soon as I did that, I saw in the video, like my palms were like bright red. I had like sores on my palms from typing for so long. I mean, I was really pushing myself. And I think what I would say to my wife was, if I was on the other side and somebody did this, and I just was on my phone one day and I found out about it, I would immediately be unavailable for communication for the rest of the day. I would walk outside and probably stare into the sun until I go blind. Like it would, it would totally, it would totally fuck me up if somebody did this. Like I don't think it can be done, so I don't think we're in danger of that. But if somebody did this, like even just trying to do this is ridiculous. Like I knew in January, let's say, when I got Conway's Game of Life running with a full WebAssembly runtime and TypeScript types, like that in itself is bizarrely crazy. Like you have to know that like that thing that we started with in the very beginning where I showed you the Conway's types, this was like totally, this 150 lines of code was like bananas bonkers when it was announced. And that was like a year before my thing announced. Like I was actually I was like 2 or 3 weeks into working on the Doom project when I talked to this guy and he showed me this. But this was like international news among TypeScript nerds that somebody got Conway's Game of Life working purely in TypeScript's type system. What? Like, but now this seems like nothing. This seems like a toy. And so I knew that difference. Like and so I would tell my wife, like, this can never be topped. Like this is so significant, and it's never been done in a programming languages type system. Period. Like so, C sharp, C++ templates, for example, the C++ generics system is known to be Turing complete. No one has done anything like this. Like whatever Diffie-Hellman, whatever there are other type systems that are known to be Turing complete. Nobody has done anything even fucking close to this. This is like very far out. And so I'm not trying to be like talk myself up, but I know because if I have sat to think about how I would feel if I were on the other side, I would just totally lose my mind if somebody did this. And so I'm happy that there are lots of people out there for which me accomplishing this made them totally lose their mind.
So
And I think that's great because it's like this. I love that I love that it's a piece of shit, stupid project. Like I love that it's not some company's product. It's a very impressive thing that some like, billionaire corp did. I love that it's just like something a dude who like did that nobody asked him to do and had no like no reason to do this other than could it be done. And like I just like the pure like human intuition ingenuity part of it. I like that a lot about this, that this is not like I didn't do this to get recognition. Like I hope that it's clear, but like I'm a kind of person and if it sounds like I make myself sound crazy, but I'll tell you guys the truth that like I'm still workshopping how to say this in a video on like describing this story of this project, but like it is just true about me that if I closed my laptop immediately after it's succeeding and never told a soul, I probably would have been about 95% as satisfied. Like I didn't do this to get recognition. And actually, for those of you who are going into industry, there are ways in which this has hurt my career. The way in which it hurts my career is really bizarre, but it's a thing that you may run into if you're into this kind of stuff. What happens is you get a persona about you and people learn that, no, Dimitri is this guy who's like really amazing TypeScript talent. And it's like, I'm not, I just got very deep on some very specific thing. This doesn't mean this is always applicable at work, although a lot of times it is. And what happens is you get kind of typecast. And so people will say, your colleagues will think like, oh, well, but he's a, high level of mastery. The truth is, you guys, like I shit code for a living. Like I put very disgusting lines of code together to accomplish a job at work because I'm very passionate about like shipping product and I like doing features and I like working with people and moving things along. And I don't enjoy making things perfect. I have never, a lot of things about this project are not perfect. And I never made them there. And I'm never going to go back and fix it. It does not bother me. I'm not going to lose any sleep. So, like career wise, it has been amazing. I can't deny that. There's lots of people from CEOs from companies I could not even believe they know who I am or respect. You know, I CTOs of various places, they've reached out to me personally saying, if you ever need a job, you come knocking. But and that's great. So I feel like the job security has been the thing that's been helpful, but it's not all roses in terms of doing a thing like this. Like people get an idea about you without really getting to know you, and I'm not complaining. I mean, I don't. It's not a bad reputation to have, but you know, it's something I've had to learn a little bit about like how people perceive this because people who get what TypeScript is and what a type system is, and that I did something like this in a type system, it's just like very hard to reconcile that with reality. I get that. I felt the same way up until I couldn't anymore when it was in front of me.
Do you like never want to touch TypeScript again, or are you still equally like
I've
passionate?
I've never really loved TypeScript. I was actually there was a language before TypeScript called Flow,
Uh-huh.
made by Facebook. And Flowtype failed. It's not, and they still produce it, and I think it's kind of a joke at this point, unfortunately. Flow really had different goals. It was trying to be completely sound and have no holes in the type system, and it was kind of closer to what Rust is in a lot of ways. Although everything has escape hatches eventually. Like, um, I was dragged into TypeScript development, kicking and screaming many years, 2015 or 2016. So I've been in TypeScript since before 1.0. Like I've been doing TypeScript since the very beginning, but um, or I guess at 1.0 in a way in production. But I, yeah, I don't know. I don't really care. I think like these things are just tools. Like we will
Yeah.
not, would be so. I'm Greek, okay, and I told you I have 4 degrees, but I only told you one of them. The other one of the other 4 degrees is in classics. I wanted to be a Latin and ancient Greek teacher, and when you spend a lot of time learning about ancient cultures and ancient people and what they did and how they pushed, you and then you go to like the Parthenon or the Acropolis in Athens, you get this feeling, and I know I'm not alone because I have other people who have like archaeologists who are friends of mine who have felt this feeling. Those people who made that stuff pushed so hard and accomplished something really incredible. And then like, so then what? 2,000 years, 3,000 years later, whatever, we're still looking at the pyramids and we're still, it's like, I think they would be pissed if I had to guess. The guy who made the Acropolis, his name is Phidias. Okay, so I think Phidias would be rip shit if he found out that all this time later, that was still considered like this amazing thing. Like I know that it's reductionist to make this point, but what I'm just saying is like I hope that we are not writing TypeScript in the future. Is it clear the connection? Like I hope that in the future there's a time but after TypeScript and it doesn't go on like it is. And so sometimes people have asked me like, what would you have added to TypeScript to make this project easier? It's like nothing. That should not have been possible in the first place. I don't want more goodies in the TypeScript type system so that I don't have to do hacks like this, like, array length thing in order to extract a number to be able to add like this should never have been possible. Hello, so I don't want them to do anything else. I want them to make it more performant, have better errors. There's like ergonomic things that could be made better, but I think the type system itself should be like a closed book at this point. Like there's things that I would, if you pushed me, I could tell you would be cool, but I don't think it needs to be more. I think we need to spend more time writing better programs. We need to spend more time working out. Anybody who's worked professionally as a software engineer is brutally aware how bad we are at creating software projects and maintaining them at scale. We suck at it. Everybody is terrible. Like the reason imposter syndrome is I think is so prevalent in our industry is because everyone sucks at this. Everyone sucks at this. I suck at it. So you go to build software in a production system and you start to feel like you're terrible at it. Yeah, it's because we're all terrible at it. So I would rather solve those problems, which are kind of human problems, than make like a type system better. I think we've done enough. Like we're still like, can we just stop writing JavaScript? Would be my preferred solution. But I'm not going to get what I want.
Dimitri, this is insane. We should probably call it because we're like
Right.
half an hour over
Yeah,
time.
yeah, yeah, of
Yes.
course.
Thank you so much for talking to us. Maybe one last thing.
Sure.
Do you have another like just unhinged, ridiculous project or in mind? Are you taking a break? Are you like sleeping? Are you getting 8 hours of sleep a night? Like, where are you at?
Squiggle Comp. Oh, wait. Oh my gosh. Okay, wait. I have to
Yeah,
what is it?
plug your shit, whatever you want.
Boston. Okay, wait. But here's the thing. Boston Comp Club. All right. You all see that in the chat?
Yeah.
Okay, 9 people. Could you please share it? Sorry, I should have said it sooner, but I made you all a discount code if you're interested.
Oh, it's sick. Okay.
It's at the New England Aquarium. If you're interested in coming to SquiggleConf, this has been one of the main things. Is like I feel very passionately like um, transparently, I will lose many thousands of dollars every year. That tens of thousands of dollars, perhaps, depending on how it goes. With running a conference of this scale, it's a 2-day conference. All of these people you see here, I'm paying to fly. Me and Josh, the co-founder, are paying to fly them in personally and feed them, and it's very expensive to run a conference. It's like tens of thousands of dollars for the venue each day and things. But I'm very passionate about this. This is something I've been putting a lot of energy into. Also I have kids, I have an 8-year-old and a 5-year-old and a wife, and they all need my attention. And so I don't really, I know it sounds strange in the context of what we just all talked about, but I'm not very ambitious. I don't think a thing like, I don't think a thing like that Doom project could be done by someone with a lot of ambition. That's just my view. I think that somebody who likes walking will walk a lot farther than someone who sprints from destination to destination. If you just enjoy the process of walking, you will go hundreds of miles past someone who's in it to win it and just run to the. It's like I just don't really care about recognition. I don't care about. I want to be safe. I want to have job security. I don't want to like just lose my. It burned me very badly emotionally to lose my job. I was not expecting it. And so like, I'm affected by those things in a practical sense, but like emotionally, I don't really care to be known as anybody or have a Wikipedia page or anything like that. I enjoy tinkering. I will be one of those people. Maybe some of you have a grandfather or a father who spent the last 15 years of their life in the basement with oscilloscopes tinkering around, and I will be that. Damn it, I will make sure of it. And so like, yeah, probably nothing. I hope I will never do anything as big as this again. That would be awesome if it is just that's it for and I can just like slowly fade into nothingness after this project and just be a nobody. That would be great. I'm on my way, I think. But it's cool to have your minute in the sun, and I appreciate the attention for the project, and I enjoy that it's motivating to people, and I hope people take things away from it that are useful about how to approach problems that are like it's such a big problem that like such an amorphous problem, and I didn't know much about how. I've never taken a computer science class. I don't know compiler stuff. Like I have books that I've read and things to try to teach myself as I go over the years, and I have on the ground game experience, but I don't think that should stop people from trying to do hard things. And I would love it if people take that away. That part I do really enjoy spreading that to the world. So yeah.
Awesome.
That's it. Any other questions? Yeah, we're good. Yeah.
Yeah, I think we're good. On that note, we will not help you slip into uh, uh, non-fame because we'll post this on YouTube and you'll get
Oh, okay.
more listens if that's okay with you. But
that's fine. Yeah, sure.
yeah, thank you so much for talking, Dimitri. This is an absolute blast.
Wonderful. Yeah, and hope to see you. Ping me or like tap me on the shoulder if you see me if you come to SchoolConf. Please, that'd be awesome. And tell people
Sounds
about
good.
it if you know. But anyway,
We'll share the code with everybody in the Slack, and so that more people will see it.
great. All right. Thanks, guys.
Thank you for this.
Okay. Thank you,
We'll see you
Dimitri.
later. Bye.
Adios.